right? We know that the wheel is a what? It's a rigid body. Okay, we are aware that the wheel is a rigid body. So from here, to find XA, we know that this is R. The next distance we have to take note is this distance over here. And this happens to be E cos theta. Okay. So again, this is where analysis come in. As I said, I was not able to figure out, and with this diagram over here, it really helped me a lot. So from here, we know that XA is equal to E cos theta plus by R. Again, immediately define E and R are constant. And theta will change with time. Right? So from here, you do dxa over dt. So this will be equal to minus E sine theta d theta by dt plus by 0. When you differentiate the radius in terms of 0, differentiate r, which will not change with time, you get 0. And then we put note d theta over dt happens to be equal to what? Omega again. Okay, happens to be our omega. So from here, we have our what? We have our velocity. We have so this will be equal to minus omega E sine theta. Okay, and then what I want to take note, right, is we have to be very careful in the sense that note again, my bad. Okay, can you do this for me, please? Can you change this to, this is equal to minus omega. Why is minus omega? Because it's going in a what? Clockwise direction. Okay, so over here we are going to multiply minus omega, and then we're going to multiply by minus E again. Okay, so this in terms will be equal to omega E sine theta. Now, why we have to incorporate the minus down here? Because the rotation is in clockwise. And when we apply right-hand rule, right? Right-hand rule specify what? Anti-clockwise is positive, clockwise is negative, right? Now, how do we know that this is right or wrong? Right? How do we know? Right? If we have not incorporated the negative sign, right, what will happen is dxa over dt will be what? Negative. Negative means what? Negative means the rod will be coming outwards. Yes or no? So velocity coming outwards is negative, is in this direction. If it's positive, velocity is going inwards. Okay. This is why I mean that in this course, you have to relate the math and the what? Physics. Okay. If the math and physics don't work out, something is wrong. Are we clear? Okay. So always remember this. I think I mentioned this to a lot of my PhD students is this. Math is always the what? The truth. Okay? If math and physics don't work out, it means there's something wrong with the concept. Are we clear? That's why mathematicians, they are always very miserable people. They are always trying to relate the math to the what? Physical world. I know that because I dated a mathematician before. Okay? Oh my God, it was like really tough. Okay? She has to put me as a function. Okay? And if the function don't work, the characteristic equation is wrong. Okay? So like really, but anyway, we move on. All right. So from here, right? From here, we can write this as dxa. So we know down here omega or E is a constant, and omega and or will change with time. Okay. So if I really write this term dxa over dt, right? Then we have this will be equal to now when you differentiate this, this is where, okay, over here this is the original equation. Okay. Over here, this is where we apply d theta over dt to be equal to minus omega. Okay. So when we are, so what we are going to do is we are going to do d square xa over dt squared. Okay, we're going to do that. But which one will you use? Okay, you use this original equation. Are we clear? Okay, so you will tend to use the minus e sine theta d theta over dt. Are we clear? Why is that? Because when you mathematically, when you differentiate this, it's minus e sine theta d theta over dt. When you apply to the real world, you put in the what? Minus omega. Why minus omega? Because this is going what direction? Clockwise direction. So when you take the second derivative, you don't take it from here. Okay, you take it from where? From the original equation. Are we clear? Okay. So from here, we know that we have minus e sine theta, and then you have d squared theta over dt squared, and then you plus where you have now you have sine differentiate, you still get minus e cos theta, and then you have d theta over dt, and you have d theta over dt twice. Okay. So from here, we know that this will be equal to minus alpha e sine theta plus by minus e cos theta, omega and omega again. Okay. So over here we have minus alpha e sine theta plus by minus e omega squared cos theta. Okay. So finally, from here, what we have is d squared x, or before we go there, we know that under constant angular velocity, alpha is equal to 0. So therefore, d squared xa over dt squared is equal to minus e omega squared cos theta. The last example I'm going to show you is not so straightforward now, okay? But it's not impossible, okay? So the last example that I'd like to show you, I will let you guys finish copying first. Okay? Right. So this is example number 3. Okay. If the wedge, okay, move towards the left with a constant velocity, determine the angular velocity of the rod as a function of theta. Okay. As I said, this is not a straightforward problem. Okay. So what we have to determine is omega. Omega of the rod. So this is our rod. The block over here, or the wedge, which they call, is moving towards the left. Okay. And you realize over here, this is what? This is fixed, right? Remember, this theory only can work when it's about a what? A fixed point. Okay. So when the wedge moves towards your left, what will happen to the rod? Is it going to rotate in a clockwise or anti-clockwise direction? Anyone? Anti-clockwise, right? So anti-clockwise direction, this is omega. And we know with this direction, omega must be what? So this is like the first hint, and this is like an intelligent guess. Yes or no? It's an intelligent guess that your omega must be positive. The difference between an A student and an A plus is the student is able to identify whether the answer is right or wrong. Are we clear? So you have to come up. This is what we call our hypothesis. Okay, so before you do any calculation, we want to know, is this right or wrong? Or what is the right answer? The right answer has to be positive. I know you guys say, Eugene, 0 to 1,000,000 is positive. I know. But you have to somehow come up with an intelligent guess, okay? So from here, we are going to determine the angular velocity okay, as a function of theta. Why we have to build this in? Because we know that d theta